Welcome to The Explainer. All right, today we're tackling a food technology that's been around for over a century, but is still, well, it's pretty misunderstood. We're talking about food irradiation. We're going to break down what it is, how it actually works, and why you might see it and why you might not.
So, let's start with a problem that I'm sure every single one of us has dealt with. Our food just does not last forever. I mean, it's a constant race against the clock from the second you get it home from the store, right? You buy beautiful fresh produce, like these strawberries, and in what feels like the blink of an eye, they turn into this fuzzy, kinda sad mess. Yeah, we've all been there.
Or how about this one? Your potatoes start growing entirely new plants in the pantry. It's like they have a mind of their own before you can even get around to using them. It's just a clear sign that nature is always at work.
But, that's just the stuff you can see. There are even bigger threats lurking. We're talking about the invisible dangers. Nasty bacteria like E. coli and Salmonella, tiny insect pests, and all those natural processes that just make our food go bad way too fast. So, what if I told you there's a technology, one that's been studied for decades, that can tackle all of these problems? That's where food irradiation comes into the picture.
And what's so fascinating is that this whole debate feels really familiar. If you go back 100 years, people were just as skeptical and, frankly, scared of milk pasteurization. And now? Well, now we don't even think twice about it. It's just a standard safety process.
Okay, so let's get into the nitty-gritty. How does zapping food with a controlled beam of energy actually make it safer and last longer? What's the secret here?
Well, the official definition is applying ionizing energy to food. All ionizing really means is that the energy is strong enough to knock tiny electrons out of atoms, which is what lets it disrupt cells. And the key thing to know is that it's a non-thermal process. So it's using this energy, not heat, to treat the food. So here's the magic trick. The whole process targets the very blueprint of life, the DNA of all those unwanted microbes and insects. It's a super precise intervention, right at the molecular level.
And you can see exactly what happens here. The energy is just strong enough to literally break the strands of DNA in those harmful organisms. And think about it, if something can't copy its DNA, it can't multiply, it can't cause illness, it's just stopped in its tracks.
But wait, there's more. It's not just about a direct hit. There's also this really cool indirect effect. The energy beam interacts with the water that's already in the food. This creates these little things called free radicals, which act like tiny temporary cleaning agents that go after bacteria and damage their cell walls.
Okay, so this isn't a one-size-fits-all kind of thing. The way this technology is used is incredibly versatile, and it really all comes down to the dose, basically how much energy you use. Scientists basically have a dial they can turn for different jobs. They measure this dose in units called kilograys, or kgy for short. So a low dose? That's perfect for things like stopping potatoes from sprouting. A medium dose can decontaminate meat. And a high dose? Well, that's for the really tough jobs, like total sterilization. And here is a perfect example of a low dose at work. Look at this. It can stop potatoes from sprouting for months and months, or it can slow down how fast tomatoes ripen. It just dramatically extends their shelf life.
Now, a medium dose is where you get really effective at controlling those microorganisms. Remember those sad, moldy strawberries from the beginning? Well, a medium dose is the solution to that story. It's also what's used to kill harmful bacteria in things like meat and poultry. And then you get to the really high doses, which can completely sterilize food. And as this researcher, J.H. Moy, points out, this is absolutely crucial for astronauts on space flights or for hospital patients who have weakened immune systems and just can't risk any bacteria in their food.
Okay, I know what you're probably thinking. All of this sounds great, but the word radiation itself can be a little unsettling. So let's get right into the big questions and tackle them head on.
All right, let's just rip the Band-Aid off. This is the #1 concern, the biggest question of them all. And honestly, the science on this is crystal clear.
The answer is a huge, definitive no. The energy passes through the food, kind of like light passing through a window. The light does its job, but it doesn't stay behind, and the window doesn't become light. It's the same idea here. The energy levels are precisely controlled. Just enough to damage a microbe's DNA, but nowhere near strong enough to make the food itself radioactive.
Okay, next up, so it's not radioactive, but does it nuke all the vitamins and good stuff out of our food?
You'd be surprised. The nutritional changes are actually pretty much on par with other things we do to preserve food. like cooking, freezing, or canning. Sure, some vitamins might be slightly reduced. Thiamine, which is B1, is the most sensitive one, but all the big things like proteins, carbs, and minerals are barely touched.
Which leads us to the million-dollar question, right? If this stuff is safe and it works, why isn't everything in the grocery store irradiated? Well, it really boils down to a couple of big things. First, the facilities are seriously expensive to build. That's a huge hurdle. But honestly, the bigger obstacle has just been public perception. That word, radiation, it just has a lot of baggage, you know? It makes people think of nuclear power plants, not safe for strawberries.
But for the products that are treated, you can easily spot them. They have to be labeled with this international symbol, it's called the Radura, and a statement that says something like, treated with radiation. So you can always make an informed choice.
So, when you put this all together, where does this leave us? What could all of this mean for the future of our food?
And you have to remember, this is not some brand new, futuristic, untested idea. We're talking about 100 years of science here. The first patents were issued way back in 1905. As you can see, it's been a long, slow, careful process of development and validation all around the world. And that really leaves us with a final thought. We have this technology, backed by a century of science, that could seriously cut down on food waste and make our food a whole lot safer. The real question for the future isn't just about the science anymore, it's about us. It's about how we balance what the science tells us with our own perceptions when we're choosing what to eat.